your diet plan according to what I teach you last week. Okay. And also, have you picked your title for your the presentation?
Dah.
Okay. At least at least one group must present one title lah. Jangan lah. I mean, everyone pick low back pain, then nobody will present bone health and then exercise for women, kan? So do you guys do that? At least one group. Yeah. Okay. Cool. And the correction. Have you done the correction for diet program? It's what we discussed last week.
Masih belum siap tapi sikit lah buat tu.
Oh, I see. Okay. So the deadline is supposed to be today, right? Or do you want me to extend it?
I would
okay.
appreciate if you want to extend that
Yeah,
time.
that time. So I'm going to extend it until Wednesday. Oh, sorry, Thursday. Boleh? So I'm going to extend it until Thursday lah. It's okay. Okay, today's class is going to be just quick. And it's actually a continuation from previous from last week about Blunt and Altman. Have you figured out how to generate the graph? Any of you? If you don't know, I just know how to do it. I just check it out. Yeah, I just want to teach you how to generate the graph, so it's easier for you to. It's not not necessary for you to do the graph. Actually, you can just monitor the number based on what we have calculated. But I think sometimes it's easier to if you can do it more visual, in order for you to identify which data is the problematic data, which one is outliers. Yeah, I'm going to teach you now just for today. Sekejap, mana tadi? Correction diet plan ni, have I? Sekejap ya. Tadi. Step 1. 3rd June, sorry. This is supposed to be not 3rd of June. Is it 3rd of June? Yes, it is 3rd of June. So the deadline for diet plan, correction for diet plan is going to be the 3rd of June. And yeah, I'm just going to explain how to generate the graph. I hope you still remember the principle of Blunt and Altman. Okay, it's basically for you to identify whether your training program is effective enough. It has many purposes. Okay, one of the purpose of Blunt Enlightenment. Siapa yang tak? Okay, one of the purpose of Blunt Enlightenment to see whether is there any changes or effectiveness of one time point to other time point, and to see your effectiveness of your training program. And then other purpose of Blunt Enlightenment is also to see to correlate one data to other data, whether to see this data has things to do with the other data. It's kind of a correlation, but in a more visual appearance. For example, you want to look into data of resting energy expenditure, okay, REE, resting energy expenditure, REE, and how does it link to Harris-Benedict equation in measuring their basal metabolic rate, okay, to see whether resting energy expenditure and also basal metabolic rate, are they really, correlate one to another? If REE low, does it really lowering down the basal metabolic rate? If it's high, that's the other data will be high. Okay, and the purpose is what I mentioned just now, to see the effectiveness of two different time points of training program. Okay, week 1 versus week 4 or week 6, to see if there are any changes and if there are any outliers, to see whether the data, to eliminate the error, okay, standard error and random error and systematic error. Now I would like to ask, any one of you know what systematic error is? What is systematic error and what is random error? Anyone? Syafiq? Syazwani ke?
Not sure ke?
Tak sure. Syazwani, anyone wish to answer? What is the difference? What is systematic error and what is random error? Whenever we collect a data, sometimes we never know that the number that we retrieve from our measurement is because of error. Okay, sometimes it's because of systematic error, sometimes might be because of random error. Okay, and Blunt and Altman can tell you whether the data is problematic or not. Okay, within your data collection, list of your data collection, data collection numbers, okay, numbers that you have collected, series of data that you have with you, by using this method, Blunt and Altman method, you can tell, okay, which one, based on 95% of significant difference, okay, between this set of data to other set of data, which of these variables is actually out from the limit of agreement. And then if it's beyond the limit of agreement, it means that that particular data is the one that is problematic lah. Either it's a random error or a systematic error, because it's out from the norm, out from the range. Okay, now the question is, do you know what is systematic error? What is random error?
Doktor, kalau tak silap lah random error tu is like macam from the error is random, means that the data changes slightly from one to another in an unpredictable manner, while systematic error more like macam it's quite consistent. The error is quite consistent throughout the data.
Can you give example, Aini? Do you look in the internet? Do you Google in the internet, or do you just understand that way?
Just understand based on the random error, systematic error.
Oh, I see. Systematic error ni basically is error when you collect the data. The process of the usually because of the machine lah, systematic error. Okay, the device, because of the device, maybe sometimes the device too is not perfect kan. Machine sometimes make error. That it means by systematic error lah. Random error ni biasanya out from the device itself lah. Sometimes because of you misread the data ke kan, you never know.
Kiranya macam random error ni is human error lah.
It can be human error. It can be human error because of the person who collect the data. It can because of the participant or the subject itself pun boleh jadi juga. It can become because of that. And it can become because of environment pun boleh juga. Temperature, out from the machine. Systematic error is the machine punya error, machine punya error. Random error is out from the machine. You can take that way lah. Okay, can you understand? Sometimes yeah. So sometimes I don't know. Maybe it's gonna contribute to just little changes, but we never know. For example, what I can give for random error is
reading of data.
Both of them
Random
reading of data. Dua-dua ni reading of data. Tapi one is because okay, I'll give you an example. Okay, you want to measure weight kan of a person. Okay, on a scale, on a scale lah, on the weighing scale. Kan machine tu dia ada dial dia kan. Dial tu kadang-kadang you never know yang dia elok ke tak elok ke. Systematic is because of the machine tu yang problem. Machine tu yang dia ada degree of error dia sendiri. We never know. Sometimes we just presume that the machine is going to give you a consistent number throughout. Sometimes it don't because wear and tear factor will give different reading. But this kind of error we call it a systematic error. Whilst random error, for example, the person wait today and the same person wait on the next day, although you have control everything, you have control their diet, you control everything, their activity. Sometimes there's a here and there that could contribute to changes in their their physiological system ke, their environment ke. Maybe today is colder than yesterday slightly, this kind of error that you can't really control that could lead to different in the reading that you retrieve. I don't know, maybe because of diet ke here and there yang dia the reading might become inconsistent compared to the previous day, or you get what I'm trying to say here? Dia tak dapat takal lah.
Faham.
Apa dia Ali? Okay, sorry about that. Okay, that's basically random error and systematic error. So, blend element will tell you which data is the one that is problematic lah, that you should ignore, something like that. Because when you're dealing with special population, you will actually collect quite huge amount of data lah, especially their body weight. That's the easiest way you can monitor their improvement, variables that easy to monitor, body weight. And if you have diabetic person, you're definitely going to monitor their blood glucose, at least kan, blood glucose. So every exercise, every session, you're going to measure their blood glucose in order to for you guys to monitor their safety, and you tak naklah you train them whilst they are hypoglycemic and something like that. And of course, you're gonna see their improvement systematically, how their glucose tolerance improve throughout your training program. So these kind of things that you must collect data. Okay, you're not gonna just simply train orang macam style kampung lah in a way. You must do it systematically to see, you know, evidence that they actually have improved. That's how you do lah. You do on special population. So yeah. Now today I'm going to teach you how to generate the blood enlargement graph that I forgot how to perform it last week. Okay. So for example, okay, this is a same data that I have last time. Okay, so presume it's not this one. Okay, it's not this one. Okay, can use this one later. Okay, so I record this lecture in case you want to watch it again. Okay, so insert and take this chart, take scatter, and then go to. Ke ada yang dah tahu macam nak buat? Ada yang dah tahu macam nak buat?
Tak.
Okay. Right, kalau dia tahu, boleh saya tengok juga. Okay, never mind. So, okay, kalau semua tak tahu tak apa, I will teach you. And then, okay again. Okay, and then go to select data. Select data, add data, name of series. Oh, so we're gonna, this is actually number of repetition, if you remember. So remember from last week lecture. Okay, number of repetition. Number of repetition. So series. Sorry. Okay. Sorry. All right. So X is the mean. Do you still remember how to come out with this? All the number. So basically, you want to differentiate between the first data set to another data set. So let's say in the same training program, for example, you prescribe, I don't know, 60% from their 10 rep max and asked for them to perform it for 4 weeks. So this is the first week, this is the 4th week. Okay. Hang on. Just to make you guys clearer. So let's say this is week 1. Data from week 1, number of repetition. Week 1, this is week 2. Then you differentiate them. You that this minus this equals this. Okay, and this is the average for these two. Okay, average of these two. And then you do everything. Okay, in week 1 and week 2. And then this is actually bias. Bias is this one. So you average all the difference. We call it bias line. While standard deviation is the mean. So, sorry, standard deviation is standard deviation from the difference. Sorry. We're going to use this mean later. I will teach you. Okay, and then, okay, after you have, I'm going to start it again. Okay, insert, take scatter plot, and then go select data, and then add. And then this is number of repetition. Okay, the first one is the difference. It can be either way, it's okay. Is why. I have a problem with my mouse. Sorry. Oh shit. sorry. Sorry, I think, yeah. One more time, guys. Yeah. Repetition. Okay. Switch supposed to be mean, sepatutnya should be. Then different is this one. X is that. Y is that. Yeah. Okay. Okay. This is data. Then select OK. You have to just delete this one. You're not interested in that. Okay. Number of repetition, and then this is the difference and mean of the difference. And then for you to draw the limit, upper and lower. Okay. You must take. I hope you still remember how to come out with this number. Okay. It is the bias minus 1.96 times the standard deviation. Okay. If you still remember, 1.96 is actually, they derive this. This is a coefficient. They derive it from the 95% of significant difference between these two data set. Okay, it's actually 95%. That's how they come up with 1.96. Okay, don't ask me how they come up with the number, but hypothetically, this is the 95% difference between two data set. Okay, same goes with t-test, other statistical analysis, significant difference. Yeah, it's the apa? Orang cakap dia punya coefficient number dia. Okay, so F55 is actually bias lah. The bias minus standard deviation times significant difference, and that is the lower limit. You have to minus from the bias line, and then for upper limit you have to just plus it lah. So it's gonna be above lah. You're gonna be above. It's the same formula, but you have just to add and minus from the bias. Do you guys get what I'm trying to explain here? Faham tak? So basically, when you want to generate a range, okay, you want to generate a range of agreement to tell all the data lies within the agreement that you have set, which is the 95%. Tangkap tak? Do you guys understand?
Yes, doctor.
Okay. Yang lain, Aini je jawab ni. Yang lain okey ke?
Okay, doktor.
Okay, cool. So, so you have come up with the bias line and also lower agreement and upper agreement, lower agreement. So now you want to transfer this into line in the graph. Okay, so for y-axis, you have to look at the range of your data here, because the data is plotted based on y-axis kan? Y-axis. Sorry, x-axis. Okay, based on the x-axis. Okay, the data is plotted based on the x-axis. You can leave this number lah, easier for you. Okay, so you have to look at the range lah. Maksudnya, what is the highest number? Usually we just put 0 for the for the lowest number, and for the highest number, you have to look which one is the highest number lah. So in this case, it's 60 something, 64. So this is 66. There's 66. Just put a number that higher than 66 lah, which is 70. So I decide to put it 70. So 0 to 70 is the x-axis. And then this is lower agreement, okay, x and x. And then this is for upper agreement, this one, okay, y, and then, sorry, this is the bias line, okay, the reference line, the lines that you going to refer all the data from, okay. So next one, Oh, ini dulu. So add. So then its value is this one. Y value is this one. Okay. Okay, that's the one. And then add. This is we draw the bias line first. Okay, bias line is axis 70, 70. 70 to 0. And next one is, so yeah. Okay, and then this is the bias line, and then add the upper limit. Okay. Upper, lower, upper agreement. Limit of agreement, upper limit of agreement. Okay, X is this one, and then Y value is for this one. Okay, then that's the upper limit. Then add another for lower limit. Limit of agreement. So same goes with this. Okay. X is 0 to 70. 0 to 70. Whilst Y is negative 5 million. Can I get rid of this first? Let's remove this one. Chow. Okay. Okay. Then Y is negative 5. 5.47730. So that's the limit of agreement. Okay. So this is actually, you can just remove it. To me, I just prefer to remove it. Okay. After all, you just interest to know how y-axis is far from the bias line, okay, of each data. So now you have to just draw the line, just draw the red to red, green to green, and purple to purple. Format lah kan? Format data series code. Yeah, I think that's the one. Line, solid line. Yeah. Solid line. You just pick anyone you like. Yeah. So yeah, that's the bias line. Let's make it black in color. Make it easier to see, to differentiate between data plot and also bias line. And then you of course draw the upper limit. Make it a bit thinner and then dashed. Okay, that's the upper limit, and the other one is lower limit. Solid line. Yeah. So basically, that's how we generate this Blount and Altman graph. So we can tell that this data here is actually the one that's problematic. You just ignore this one. Might be due to error or combination of both random and systematic error. Okay, you just choose this one. And from this, you can also see how many differentiates lies below the bias line. So you can tell that most of the data from your data set is reduced, meaning that reduce in performance. So you there's something you need to do to maybe improve or increase the intensity to see more improvement in their performance, or any physiological changes. If you measure glucose, you must make it improve, something like that. You know what I mean, right? So the difference should be either improve or reduce, depends on what your objective is. Okay, so yeah, so I'm going to compare this with another training program. Okay, another training program. So yeah, this is the example that you get, that if you see number of repetition, difference number of repetition from one data set to another data set, it's better compared to the previous example that I provided. And also it's close to the bias line. Close to the bias line, as it means that it's very much reliable, very much reliable. Yeah. So yeah, do you have any question? So now I believe you can generate the blood endowment graph for you to assist you when you evaluate your training programs to your clients. Okay, any question?
Doctor,
Yep.
the solid number of week 1, week 2 tu kan, solid yang whole number tu sebenarnya number apa?
This one good.
This
is number of repetition. Performance.
Okay.
In this case, this is number of repetition. Maksudnya the person, this is just a random example. For example, in week 1, you do how many? Let's say you do how many session? Ada week 2, in a day maybe ada 2 session. I don't know. You can just come up with any number. Like it's not necessary this amount. And the person perform leg extension to exhaustion, and this is the performance that you collect, the data you collect. Session 1, session 2, the next day session 1, session 2, next day session 1, session 2. Okay, and then this is for week 1, and then this is for week 2 under the same training program lah. Under the same training program, you cannot compare apple to orange, kan? You cannot compare week 1 ni, for example, 60% from 110 rep max, and then week 2 ni slightly higher, 70%. You cannot do that. Of course, they're going to improve performance. What you're trying to measure here is within the same training program, within the same intensity, do you see any changes in their performance or their physiological variables, markers, blood markers ke apa ke, within the same training program? Dapat tangkap tak? It can be anything.
Dapat.
This can be any variable. Okay, cool. So any other question? I think that's everything for today. Go. Yeah. Kalau tak dapat tangkap, you can always watch the video again lah later. I think you can get access to the video through your Google Driver, kan? Or do you want me to upload this in Spectrum?
Upload Spectrum lah, Doktor. Saya rasa.
Okay. I will upload this in Spectrum. So I hope you understand the concept of blood endowment. And apply this when you work out there, and whenever you have, especially special population client lah, to see improvements in either performance or their blood markers, apa-apa sajalah, all the variables to see whether your training program is effective. Okay, thank you so much, everybody. Thanks for your time, and please don't forget to,
for the presentation, it is a recorded presentation, right? The presentation that you have given.
No, not recorded.
Not recorded?
No, it's not recorded, so everybody. No.
Oh, it is live presentation to you lah.
Live presentation. So everybody wants to listen to you lively.
So when is it the date of presentation?
Sekejap, I pun dah takut miss up dengan other course. Is it live ke recorded lah? Sekejap. Let me read again. Pick one of the 30 positions should be two groups. Simply attached together and exposed. Okay, I will make this open. Do you prefer recorded or live? I prefer live lah, honestly. 30 to 40
But I
minutes.
think Doctor, if we have live presentation, 30 minutes is too long. So I think I would prefer recorded.
Okay. If that case, then how I'm gonna ask question. Okay, I have no problem. If you prefer it to be pre-recorded, and let it be pre-recorded lah. And then send the link to the assignment ni lah. And then I'm gonna just evaluate from there. Can it be like that?
Okay, Doctor.
Cool. So yeah, thank you so much. Is there any other question?
Doctor, I have a question.
Submit tu sekali dengan ni lah. Dah siap recorded presentation lah. Hari 7 hari bulan ni.
Aha, sempat tak korang nak buat?
Tak sempat, Doktor.
Tak sempat. You want me extend?
Yes, Doktor.
Yeah, sure. Boleh. Bila you think you can? I understand. You must have quite, number of assignment to submit then, because this is end of the semester. When you think is most feasible time that you can submit?
Adding one more week, I think
14 or 16?
16.
16. Sure. Boleh Kalau nak 23 pun tak ada masalah. Okay je.
Bila?
Bila ni? You must let me know. Pick one date.
16 Doktor?
Come again?
23 pun okey kan?
Tak dengar lah. Apa?
16 okey.
23 pun okey.
23.
23rd. Nak buat 16. Okay, so 16 ke 23rd?
I would probably prefer 16, Doctor.
Okay. Is everyone agree with 16 June? Semua setuju ke 16? Okay, alright, cool. So 16, okay. We're gonna do it on 16 lah. The deadline is on the 16th. We're just gonna straight away change the deadline. Sixteen. Okay, any other question or any other query?
Doktor, ada question pasal the correction of the the tuition table tu.
16. Yeah. Kejap. Let me correct this first. Okay, apa dia soalan dia?
Yang towards the end yang ada pasal doktor kata kena kira calorie for protein, carbohydrate, fat and
Yes.
fiber tu semua kan?
Betul.
Yang tu ambil
Okay.
from dekat mana out of the data yang kita dah bina tu.
On video. Kejap.
Okay.
Yeah. Okay, maksud you macam mana nak calculate macam mana nak calculate number of calorie?
Yang tu yang macam protein fat tu semua saya tahu ikut lah macam 1 gram yang 449 tu. But like macam the benda untuk kali dengan 449 tu apa, yang mana satu?
Yang mana satu? Yang daripada total carbs, daripada kalori yang setiap meal tu lah. I'll show you.
Okay.
Bukan macam tu, Doktor. Dia macam kan ada komponen the carbohydrate, protein, fat and fiber, is it? Kalau for the table yang Doktor tunjuk tu, you anchor it to the carbohydrate. So I understand the carbohydrate is coming like from the total daily intake. But then where do we get the fat and also the protein? Do we like just assume, or Is there like we need to do a calculation as well?
Okay. Right. Kenalah calculate carbohydrate, protein and fat tu is based on do you remember that you apa tu? Dekat dalam 100 gram tadi tu kan, 100 gram of each
ingredients put per 100 gram awal tu.
Yes, correct.
Okay.
Take from there. I'll show you.
Okay.
Simpan. Yeah, I think this one too. Yeah. This one then.
Yang tu.
Okay. Yeah. This one comes from protein, carbohydrate and fat ni comes from this one. From 100 gram or 100 ml of your ni lah, of your formula recipe tu. From the label behind tu, and then per 100. Okay, let me show you the equation. So the cereal ni times your punya per 100 tadi tu. This one, okay, cereal. Okay, usually, you know, I will do ni dollar symbol ni. Okay, dollar symbol ni untuk log di cell tau. Do you know that function?
No, doctor.
Okay, I will explain you one at a time. Okay, untuk protein, of course you're gonna refer back to protein ni. Protein ni kan. Sebab you can refer back to label for every ingredient that yang from your recipe tu kan. Take that everything out, all the macronutrients, okay, including fiber, and of course energy juga. Energy kalau if not mistaken memang ada sekali kat belakang tu, memang ada per 100 gram ni or per 100 ml ke memang dia ada amount of calorie, either in joule or kilocalorie. And then okay, your carbohydrate, protein ni from your cereal ni, gram of cereal, remember that the last table tu is the mass, the weight of the weight of each ingredient. Remember, gram of cereal, milliliter, how many liter of milk, gram of bread, that will make you know, the cereal meal punya meal tu. Okay, from the weight ni, okay, times this one, times this one, times this one, okay, divide by 100. So you're gonna get the amount of protein out of this portion. Dapat tangkap tak?
Dapat.
Yeah, over 100 because over 100 is because dia punya ni is 100 lah. Sebab tu kita ambil 100. Okay, dapat tangkap And you kena letak simbol dollar ni tau. Simbol dollar ni dekat in between huruf ni, huruf sel ni. So nanti dia akan terus lock yang ni. Maksudnya kalau you tak buat macam tu, dia akan ambil yang bawah ni. Dapat tangkap tak? Jangan tinggalkan dollar sign tu. Dollar punya sign tu jangan tinggalkan. Dapat tangkap ke? Boleh And then plus Okay, belum tak habis lagi. Ni tak habis lagi. Plus, because untuk cereal meal ni, remember dia ada banyak komponen lain lagi. Dia ada komponen milk dengan bread lagi kan. So you have to add yang the rest lah. Protein, protein from milk, protein from bread, protein from jam, protein from butter, of course, last but not least, orange juice. So you have to remember yang ni adalah komponen untuk setiap semua meal ni. Protein of this breakfast meal ni semua, or lunch meal of that particular meal lah, easy to say. Okay, plus, and then it come out with the protein, total number of protein of everything that you eat in the morning. Okay, same goes with carbohydrate, same goes with fat and also fiber. And from this, you can come up with energy, okay, either in kilojoule or kilocalorie.
Yang energi ni pun kira yang sama kan macam tadi.
Kilojoule ni you can just convert je nanti. Lepas dapat kilojoule ni, of course lah you takkan from this you can generate this based on 1 gram equals to 4 kilocalorie itu. This is this one.
Okay.
Kan, maksudnya protein ni per gram tau. Per gram, per meal ni. I'll show you. Okay, so T6 times D ni, times T6 ni, 13.3 times D15 ni is protein of that, and then plus 100 gram ni kan, this one, and then blah 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 blah, and then there you go, the number of calorie of that particular the whole meal, serving of this meal lah. Tiga komponen ni. Dapat tangkap tak?
Tambah lah. Tambah tiga.
Tambah. This part ni ada 3 komponen. Protein, carbohydrate, fat. Fiber ni you don't put in lah. Just macronutrients saja. Boleh juga sebenarnya nak tambah fiber. Ada sebenarnya. Fiber also contribute to certain kilocalorie, but it's too minute lah. If you're not precise, then I have no oblige lah for you to include that in as well. Fiber, I'm not sure berapa dia punya gram. You can check lah, but I'm more interested in macronutrients rather than fiber. Fiber doesn't really contribute to energy sebenarnya. Okay, so this is the number of kilocalorie. This is the amount of calorie of this person who weight 70 lah ish. So the meal will provide 53.8 kilocalorie lah for this guy. Okay, and this is the composition of protein, carbohydrate and fat. If you want to convert in percentage, you have to change this in kilocalorie first lah. Protein ni into kilocalorie first. You know how to do that, right? Protein, this amount of protein in gram into kilocalorie. Kan? You know how to do that kan? So, and then divide by energy and then times 100. So you know the percentage of this and this in percentage form lah for each macronutrient. Okay? Dapat tangkap tak?
Energy kilocalorie tu tadi macam mana doktor? Energy kilocalorie ni okay,
ini sebab derive it from kilojoule.
So macam bahagi macam tu je lah daripada kilojoule.
Yes, but 1 kilojoule equals to 4.184. So I divide these to this lah, this number to make it in kilocalorie. So, but yang kilojoule ni is constitutes from these 3 times 100 gram tu tadi, or 100 mil. Okay ke? Dapat tangkap ke? Kurang. Okay, dapat tangkap tak? Boleh? Okay, any other question? Okay, so ada soalan lain? Okay, 1 gram. Okay, this is gram. 1 gram equals to how many? 1 gram equals to, this is the kilojoule unit. Is it 1 gram equals to, okay, oops, sorry. So 1 gram, okay, this is joule tau. So 1 gram ada 16.74 kilojoule of carbohydrate. Energy from carbohydrate, 1 gram. So this one times this lah. This one times, shit, okay, this one times yang tadi tu protein, carbohydrate, fat tu, and then tambah. Dapat tangkap kan? Boleh? 1 gram tadi. Okay, ni dulu. Ada soalan lagi? Tak ada soalan? Ada soalan tak?
Tak ada dah rasanya doktor. Okay dah.
Korang tengah try buat ke apa tu?
Tengah menelaah.
Okay. So kalau ada apa-apa soalan, just pass me lah. Okay, thank you so much everyone. Thank you so much. Don't forget attendance again. Assalamualaikum.
Thank you, doktor.
Thank you, doktor.
Bye.